once we encounter alien intelligence superior to ours, we might have a sense of awe. And I think in the distant future, that would be the new religion. In reality, that is just a neighbor that happens to be much more wise and capable than we are. For us, it will be a learning experience. Microbes would have survived it if they were in the interior. So these were the first tiny astronauts. What Elon Musk wants to do going to Mars is just like going back to our childhood home if we are all Martians. What I would like to know is whether Mars developed intelligent life in the first 2 billion years of its history, and there might be some interesting paintings in the lava tubes or the caves under the surface of Mars. I would like to go there with a video camera and check. I would argue the foundation of science is the humility to learn, not the arrogance of expertise.
You really think you're alone in there?
On the very day that this interview is published, something interesting is happening in space. The third interstellar object ever to be discovered is passing at its closest point to Earth. On this historic day, we're talking to Avi Loeb. He's the head of the Galileo Project, the first systematic scientific search for extraterrestrial technological artifacts. In this episode, we're going to discuss why it's very arrogant of us to assume that we're the smartest kids on the block, or that we are alone in the universe. If you've ever wondered if there's intelligent life in the universe besides us, and if so, why we haven't seen any evidence of this, this interview might give you a glimpse into the reality of the situation. Let's dive in.
Wes and I do, so sometimes we regret things.
Do you have skeletons in the closet?
It's too many. I'll let the editor know.
No.
Spilling out. Just kidding. I don't know. No, we're pretty good.
My name is Avi Loeb, and I'm a professor of science at Harvard University, the director of the Institute for Theory and Computation, and the head of the Galileo Project right now. And I used to have many other leadership positions over the past decade.
Phenomenal. Thank you so much for being here. We're so honored. We kind of wanted to present this to our audience. Lots of conversations about, for example, 3I Atlas. In fact, if I'm correct, the release of this interview will coincide with 3I Atlas passing at its closest point to the Earth. So I think that's kind of exciting. But so I think most people who don't follow this stuff would be surprised to find out that we've observed only 3 interstellar objects. We have the ʻOumuamua, Borisov, and now Atlas. So can we talk a little bit about that? Why is this? Why are we only now beginning to see them? What makes them so special? And kind of wherever you want to take that.
It's like most things in science, nature is more imaginative than we are. So for some relatively simple-minded reason, we end up discovering something new. And in this case, it's the US Congress that tasked NASA to find 90% of all objects bigger than a football field, 140 meters, back in 2005. And as a result, a survey telescope called Pan-STARRS was established in Hawaii, and it discovered a near-Earth object. So the reason the Congress tasked NASA to do that is because such objects, if they collide with Earth, they can cause a lot of damage. We know the dinosaurs were killed 66 million years ago by an asteroid the size of Manhattan Island. We believe that we are smarter than dinosaurs. We can protect ourselves, maybe deflect those rocks. So anyway, they spotted a near-Earth object, but realized, the astronomers back on October 19th, 2017, that in fact, this one is moving too fast to be bound by gravity to the sun, and it came from outside the solar system. So that was the first one. It was given the name ʻOumuamua, which means a scout in the Hawaiian language. And then it became quite strange once more data was collected about it, because it had a very extreme shape. The amount of sunlight reflected from it changed by a factor of 10 as it was tumbling every 8 hours. And it was most likely flat, like a pancake, based on the variation of sunlight. And moreover, it was pushed away from the sun by some mysterious force without showing any evidence for gas or dust around it. So, it was intriguing. But then by chance, an amateur astronomer discovered the second object back in 2019. And then most recently, there is a a survey telescope that NASA funded in Chile, a very small one, 0.5 meter in size, called Atlas, and it discovered this new object, the third one, 3I Atlas. I stands for interstellar, 3 the third one, and Atlas is the name of the telescope that discovered it. And why did we find only 3? Because we were not looking for them, and these survey telescopes were not very efficient at surveying the sky. However, now we have the Rubin Observatory that was funded by the Department of Energy and the National Science Foundation that started operations in June this year with a 3.2 gigapixel camera in Chile, and it will survey the southern sky every 4 days. And potentially find a new interstellar object every few months. So that would increase by 2 orders of magnitude the rate of discovery. But as I mentioned before, we just found these objects by chance. In fact, there is a 4th object that I discovered with my student, former undergraduate student, Amir Siraj, where we looked at a database on meteors and found that one of them from 2014 that was identified by US government satellites was moving very fast. In fact, the same speed that 3A Atlas is moving outside the solar system. And we, in fact, called it an interstellar meteor. And I led an expedition to the Pacific Ocean to look for the materials of that one. So it's a new frontier, and the reason it's exciting is because even if we are talking about rocks and natural objects, that offers us an opportunity to study the materials arriving to our backyard from a distant star. And, instead of us spending millions to billions of years traveling to other stars, here we have objects that made that trip, the very lengthy trip, and arrived at our backyard, and we better take advantage of that. And the mainstream of the scientific community haven't yet realized this opportunity, because we can check for the building blocks of life around other stars if we find a rock that arrived from our cosmic street. And so I see that as a very important frontier for the future, because if we happen to find a technological object, we might even learn much more than from a rock, because we will realize that there is a smarter kid on the block that managed to arrive to us before we arrived to their backyard.
Absolutely.
Yeah. Yeah, because I would have thought that there were billions or maybe even trillions of interstellar objects. So the whole idea when researching for this video that there's only been 3 or we don't do a good job detecting them kind of blew my mind.
So let me correct that impression, because if it's a rock, let's say we see a rock within the orbit of the Earth around the Sun, a rock coming on a random trajectory, the entire volume of the solar system is a quadrillion times bigger than the volume associated with the orbit of the Earth around the Sun, because the solar system goes all the way out to the Oort cloud, which extends to 100,000 times the Earth-Sun separation. So this means that if you find one object, let's say every year, within the Earth's orbit around the Sun, then there should be a quadrillion of them right now within the solar system. A lot. However, if it's technological, it could target the inner solar system, so this extrapolation is incorrect because it doesn't reflect a random distribution. But all natural objects that are on random trajectories, there are many, many of them, a quadrillion of 10 to the power 15 of them right now within the solar system for every one that we find within the Earth's orbit around the Sun. That's the case, for example, for the abundance of objects like ʻOumuamua that are expected to have a number density of that much if ʻOumuamua was natural.
Yeah, and it would be hard to rule out something like Panspermia until we look at a lot of those objects to see what's on them.
Yeah, this is a very interesting point, because 3I Atlas was recently found to spread methanol, and methanol is one of the building blocks for amino acids and sugars that are used for life as we know it. And so it's spreading much more methanol, 100 times more methanol than, for example, hydrogen cyanide, which is at large quantities is a poison for life. It was used in the First World War by the US, Italy, and France as poison gas, as chemical weapon. So the good news about 3i Atlas is that it's spreading much more of the building block of life than poison for life. And so you can think of it as an interstellar gardener. So in principle, you are exactly right that there should have been a lot of those coming through the solar system, during its history of 4.6 billion years. And therefore, it's possible that life was seeded in the solar system from outside, potentially, and that's just assuming a random process. But if there was an interstellar gardener with intelligence, they could have come here just to spread the or do experiments in the origins of life, and maybe when they were unhappy with what's coming out on Earth, they sent the asteroid that killed the dinosaurs. Who knows?
Yeah, there's a lot to think about. It's such a fascinating thing to think about that it could have come from elsewhere. Now, growing up, reading a lot of science fiction books, like there's this idea of a light sail traveling across a vast distance in space with a light sail. Of course, the ʻOumuamua object, maybe it seemed like maybe it was operating with some sort of technology like that. Of course, recently we've also had confirmation that it's possible for us to use it. We've had some experiments where we were able to use light sails to move a spacecraft. Can we talk a little bit about that? And how are you using it?
In fact, I led the Breakthrough Starshot project, which was aiming to develop a light sail so that we can reach the nearest star within 2 decades, our lifespan. And the idea was to use a very powerful laser that with 100 gigawatt that shines on a light sail that weighs only a few grams and carries a camera with it and so forth. And within a few minutes, you bring it to a fifth of the speed of light across a distance that is 5 times the distance to the moon. And such an initiative could have launched a light sail that would have reached the nearest star system, Alpha Centauri, during our lifespan. And that's the only method that can work this way right now, based on what we know. So we did conceptualize what are the technological requirements, and in principle there are no showstoppers for this technology. And of course there are many other incarnations of light sails that are using much lower speeds, not a fraction of the speed of light, but maybe a percent of the speed of light, just using the push from sunlight, for example, and not a very powerful laser. And what happened in the case of Oumuamua is that it was pushed with a force that declines inversely with distance squared from the sun, and I suggested maybe it's just the reflection of sunlight that is pushing it. It's not the rocket effect from a cometary evaporation. And indeed, 2 years or 3 years later, the same telescope in Hawaii discovered an object that was pushed by reflecting sunlight, and it was given the name 2020 SO, discovered in September 2020. And then within a couple of months, they took a spectrum of this object and realized that its surface is made of stainless steel. So then they figured out that it's actually a rocket booster that was launched by NASA in 1966. And it's pushed by reflecting sunlight because it's hollow. So here you have an example by the same discovered by the same telescope in Hawaii of a technological object that behaves in a way similar to Oumuamua. And to me, it's a demonstration that the training data set of comet experts should be expanded, because they behave just like AI systems. They were trained for decades on icy rocks in the sky, and they interpret any object in the sky as an icy rock. What do you expect? But I'm just suggesting that I beg them to expand their training data set to include technological objects, because we launched such things, and we know that they supplement the rocks that exist up there. And you might say, oh, well, we don't know. They don't get confused. They know what they're doing. NASA is definitely a set of experts. Well, I would argue the foundation of science is the humility to learn, not the arrogance of expertise. Because on January 2nd this year, there was a near-Earth object that was cataloged by the Minor Planet Center, the comet experts of the world, they treated it as a near-Earth asteroid. And then within a day, they realized that it's moving along the path of the Tesla Roadster car that was launched by SpaceX in 2018. So they said, sorry, we take it out of the catalog. It's not a rock, it's a car.
Right.
And I'm saying the only reason they knew that is because they were aware of what we launched. But if someone else launched some technological object that we don't know about, they would still insist that it's either an asteroid or a comet. So when NASA says 3I Atlas behaves like a comet, and therefore it must be a comet. If it quacks like a duck, walks like a duck, it's a duck. What do they mean by that? They mean that it sheds some dust and gas around it from its skin, from its surface. Well, guess what? Any object that accumulated ice throughout its journey and some dust would shed it when it comes close to the sun. So if you see a cloud of dust in the desert, you might argue, oh, that must be some animal making this dust, and therefore, it's a natural phenomena. But at the same time, it could be a car going through, producing the same cloud of dust. And NASA would say, it looks like a cloud of dust from an animal. It must be an animal, but that's not the reality of the situation, because you can't judge a book by its cover. Okay, it's a very simple point that we need to verify, because when we have a visitor to our backyard, we don't have the luxury of NASA experts being wrong. For the same reason that on October 7th or on September 11th, we didn't have the luxury of the intelligence agencies being wrong. They were wrong, and lots of people died because of that. So when you have an impact on society, then the standard scientific procedure of saying at the 95% confidence, I can tell you what it is, well, that's not good enough, because a 5% probability of you being wrong and this event being of large impact on society, implies that we must take that chance seriously. And that's what intelligence agencies concluded after the mistakes they've made on September 11th and October 7th. So, it's a very simple point that scientists fail to understand, that when you deal with implications to society, I realize most of the time scientists have no implications to society. I mean, they deal, like, for example, last week, there were 2 experiments that checked for a ghost particle known as sterile neutrino. It was conjectured to exist because there were anomalies in some previous experiments. They put $90 million in these 2 experiments, and then in Nature magazine, they reported that they haven't found those signatures. This particle does not exist. Okay, so they were wrong. Mainstream experts arguing we should fund these 2 experiments for $90 million, and were really believing that such a sterile neutrino may exist. They were wrong. Now, this has no impact on the life of just the public, private citizens, because even if the sterile neutrino existed, it wouldn't have any effect. So the fact that it doesn't exist doesn't mean anything. However, when dealing with a visitor to our backyard, there is a chance that if this visitor, has some intelligence to it, it might come through our front door. So we can't ignore that risk.
Right. So you are in a position now where you have a company, the Galileo Project, and you have some funding. So you've got a chance to look at the future of astronomy differently. Now, it seems to me, as somebody who thinks about AI a lot, you could start training. You could be the first in the world to start training telescopes on data that would allow you to see signatures from machines. You could have signatures from all sorts of synthetic data and anomalies that might give you a clue as to where to point the telescopes for future research. How are you using AI and technology to do things differently?
Yeah, that's an excellent question. My approach, since our imagination is not necessarily as good as nature itself, that we might, if I were to try and imagine what might be out there, then I might not actually include in the training data set what needs to be included, and so we should not subscribe to the imagination of script writers in Hollywood, the science fiction stories. My approach is different. My approach is, we know the kind of objects that are either natural or human-made. Okay, so that includes birds, airplanes, satellites, helicopters, planes, all the objects that we are familiar with. Given that, we can train our machine learning software on these kinds of objects because they are familiar, they are around, and we can, of course, train them on different times of the day, different illumination levels, different angles relative to the sun, and so forth. It's a very rich data set that needs to be studied, and obviously we can train them on real data because most of the objects we see in the sky are just ones that are familiar to us. Okay, and then the only question that remains is, are there any outliers? And there are different ways to characterize that. I mean, if you have a distribution of objects, the way they can look like, the way they can move, you are looking for things that are far in the tail. Now, when you have a small number of objects, then of course you don't know the probability distribution very well. You can be wrong, and that's a mistake that a lot of people that go on dates, make, because they meet someone, that someone looks exceptional, but their sample of the probability distribution of qualities of people is very limited, and so they think it's exceptional. They get married with that partner only to find out that there is nothing really unusual about that partner, but it's too late. And that is done very often, okay, because you're not familiar. In order to sample the entire probability distribution, you need to go on a lot of dates. And the question is, how many is enough? Well, it depends how many sigma, how many standard deviations you want to go outside of the mean. If you are happy with the mean, just marry the first person you find. I mean, that's fine. Anyway, so this is important, of course, to sample the probability distribution and figure out what defines an outlier and how unusual is the outlier. But it's not just about the image or the way the trajectory looks like. It's more also about the speed, the acceleration, all kinds of features of that object, whether it's outside the performance envelope of known familiar objects. So if we see an object moving extremely fast or accelerating very fast, then we know human-made technologies cannot make it because there are limits on the propulsion systems that humans use. So my approach is looking for outliers. That's what we do in the Galileo Project. And as of now, we have 3 observatories, one in Massachusetts, another one in Pennsylvania, and a third one just constructed in Las Vegas, in Nevada. And we will collect data on millions of objects per year and look for outliers. And if we find anything extremely unusual, obviously we will put it in a scientific paper and submit it to peer review. Everyone will be made aware of that.
That's absolutely excellent. And so when we're talking about trying to find these outliers or searching for stuff, I mean, we can look with, kind of in the solar system. We can look in for maybe even for some things in the atmosphere. There have been talks about various unidentified things flying around. And of course, we can also look into very, very far distances. I think you had this sort of example or way of looking at it. Like if you think about like being on a street, you have a lot of houses, we might throw a rock out there. Somebody might throw a rock out there. But another way of approaching it, maybe to try to see if we can see any visible signs of construction across the street or down the street. Maybe if we spot something like a Dyson sphere or a signature that could be like a Dyson sphere somewhere out there, that would certainly have some technological signature to it. Can we talk a bit about that? Is there any efforts to look into the far distances for that?
Well, there were studies trying to find evidence for Dyson spheres, and the problem is that we now know that young stars are often surrounded by debris disks. These are still the structures that were responsible for feeding the central star with material, and there is some leftover material in those debris disks, and in principle that material can scatter the starlight and appear as if there was some mega structure, but it's that emits in the infrared, but it's not really a Dyson sphere. So the idea of the Dyson sphere is that you put, for example, at the Earth-Sun separation, you put a megastructure that collects much more sunlight than the Earth's surface, and But such a thing will be impossible to hide because it will still get relatively hot, roughly the surface temperature of the Earth, and then it will emit in the infrared. So, and then you can search for such structures in the infrared, but the problem is debris disks are also extending across similar scales, and they also produce infrared emissions. So we need to distinguish a Dyson sphere from other infrared emitters around the young stars, and that's. But there was no clear evidence for such a megastructure as of yet. I should also mention that stars evolve. Okay, so even if a civilization were to build a Dyson sphere or a megastructure to collect the starlight, once the star brightens up, it may break it apart, and that would lead to lots of fragments in interstellar space that we can search for. And I suggested in a paper that, in fact, maybe ʻOumuamua was a broken piece of a Dyson sphere, because then the simplest engineering approach to a Dyson sphere is to have them as light sails. To make a Dyson sphere out of lots of tiles that are just hovering above the star, where the radiation pressure from the star keeps those tiles afloat. It just balances gravity, and so these tiles are floating as if they are at zero gravity over the star and collecting starlight. But then if the star, for example, brightens up like the sun will in a billion years, it will push these tiles out of the system, and maybe ʻOumuamua was a broken piece of such a Dyson sphere. So in interstellar space, you might find debris from all these constructions that perhaps were active for a while, but then got destroyed. Another risk for such a megastructure is the impact of asteroids. If you calculate it, such a structure cannot survive more than 1 billion years because, in a solar system like environment, because there's too many rocks flying by, in our case, from the asteroid belt, and they would basically puncture the structure and destroy it. I did a calculation. There would be too many of them moving at a very high speed that deposits more energy than an explosive whenever they collide with such a megastructure, and eventually break it apart. So you would lose it. So such megastructures would exist always just for a finite amount of time, and we need to be lucky to catch them when they are active. For the same reason that we need to be lucky to get a phone message, a radio signal from a civilization, which was the traditional approach for SETI, for the search for extraterrestrial intelligence. And I'm just saying, if we search for any packages in our mailbox, we don't need to know that the sender is still alive. The sender may be dead, even if we have found something in our backyard that was sent a long time ago, billions of years ago. It's still around. It's bound by gravity to the Milky Way galaxy, so it's not running out of the Milky Way. Like radio signals are moving at the speed of light, and they are lost after they cross us. So this is a completely different approach, and I believe it's more effective. And I believe that we should invest as much research funds in searching for those physical objects as we invest, as we plan to invest in the search for microbes, because microbes, as much as they might be very abundant, they are difficult to detect, and technological signatures might be easier to detect. So let's hedge our bets and search for both. So this is not a popular view, by the way.
Sorry. Is it possible to just look at the direction that something like this came from? So we have these 3 interstellar objects. Can you, like in a normal world, if somebody threw a snowball at you, you would turn around and say, who threw that? Can you do that? Or is it because so many things with gravity twist and pull and push it, is it kind of impossible to tell where 3A Atlas came from?
No, it's not impossible for the reason you mentioned. It's impossible because we don't know the duration of the journey. Okay, so if you just trace the trajectory back in time, even if we had a perfect understanding of all the twists and turns because of gravitational deflection within the Milky Way galaxy of the object, as you go back in time, you just don't know where its starting point was. And in fact, the Oort cloud of the solar system goes halfway to the nearest star. Okay, so if the nearest star system has an Oort cloud, then these are densely packed, just like billiard balls touching each other. And so pick a direction, and you can cross lots of Oort clouds around many stars along the path. You just don't know which one it is. Where did it come from? Which star did it come from? And what was the mechanism that ejected this object? And so it's impossible. I mean, I should say that there were a lot of papers written about where these objects may have come from. And one approach that, together with my undergraduate student, Shokruz Kakarov, we studied was to trace the trajectory back in time and ask, if you look at the motion of the interstellar object, what population of stars could it have originated from? So in the case of ʻOumuamua, it must have originated from a young star in the thin disk of the Milky Way galaxy, because it didn't deviate much from that population. But in the case of 3i Atlas, it was moving relatively fast before it entered the solar system. So it should have originated from an old star, because old stars are kicked around for much longer and they acquire bigger velocities. And based on the high speed of 3i Atlas before it entered the solar system, it would be natural to link it to the population of old stars that are of order 5 to 10 billion years old, older than the sun. And so if you just made the rough inferences, you might say 3i Atlas, if it's natural, originated from a star older than the sun. ʻOumuamua, the first object, originated from a star younger than the sun, because it had nearly no motion relative to the local standard of rest of the Milky Way galaxy.
Interesting. And so, we have some theories about where life maybe could have originated. If it wasn't on Earth, maybe it came from maybe Mars. Potentially Mars had some sort of life at some point, and eventually, it extinguished there. We have life here. Potentially, maybe it was transferred from Mars to here. That's one of the possible hypotheses. It seems like there's some structures on Mars that are a little bit too geometric, a little bit too precise to be maybe natural. Can we talk about that a little bit? Like, do you view that as a possibility that there was a civilization or at least a life on Mars at some point? And anything about that?
Yeah, I mean, I was asked this question by Joe Rogan a month ago, and the evidence is not at all clear. It could be that we are looking at rocks with some unusual shapes. And obviously, Mars was bombarded by rocks from far away, not originated on Mars. And it's just a museum that preserved those rocks, because over the past 2 billion years, it didn't have an atmosphere. So on Earth, when a rock of less than a meter enters the atmosphere, it burns up in a fireball because of the friction with air. But over the past 2 billion years, all the objects that impacted Mars did not burn up in an atmosphere. They just collided with the surface, and you could find them there. So that implies that Mars is a museum that collected all the objects, and we just need to do some archaeological digs there, or survey the land and see if there are any unusual objects. That could include natural rocks from the solar system or from interstellar space, but also potentially technological objects. And I think it's a very interesting study to make. And I would also be curious to go into the caves on Mars, because in the first 2 billion years of its lifespan, it had an atmosphere. It had liquid water in the form of lakes, rivers, and oceans, just like Earth. And in fact, it cooled before Earth did. So life should have started on Mars before it started on Earth. And maybe it was transferred to Earth through rocks that came from Mars, because there was a heavy bombardment by rocks in the first hundreds of millions of years, and that could have chipped rocks from the surface of Mars that may have had life first, and brought them to Earth, and in that case, all these microbes that managed to survive in the interiors of rocks, because the rock itself didn't heat too much. We have one example where it didn't heat more than 40 degrees Celsius. A Martian rock that was studied about 45 years ago was inferred to not have suffered the very extreme heating, and microbes would have survived it if they were in the interior. So these were the first tiny astronauts, and what Elon Musk wants to do, going to Mars, is just like, in that case, would be just like going back to our childhood home if we are all Martians. But what I would like to know is whether Mars developed intelligent life in the first 2 billion years of its history, and it's just a factor of 2 faster than Earth. There is nothing to forbid it from doing that, just twice as fast as Earth. And in that case, there might be some interesting paintings in the lava tubes or the caves under the surface of Mars. I would like to go there with a video camera and check. And it could be really interesting. Of course, it was likely, there was very likely life in primitive form on Mars as soon as it cooled, just like it happened on Earth.
Wow, space archaeology. That's a great job for somebody who's born today to build their life around.
Yes.
Let's talk about the Fermi paradox. So that's the question that asks, is the universe, like, if the universe is so old, why don't we see any evidence of intelligent life out there? Like, what's your take on the Fermi paradox?
Well, I think it was quite unfortunate that Enrico Fermi, who was an experimental physicist, asked the question this way back in 1950 while having lunch at Los Alamos. And if I were there, I would put my arm around his shoulder and said, Enrico, you're not that attractive. That's a question that every lonely person asks. And what you tell a lonely person is, you should be more proactive. You should go to dating sites. Don't expect your partner to show up at lunch in Los Alamos when you're asking this question. That's what you tell your friends when they don't have a partner. They usually say there is nobody for me, but they're not searching actively. And Enrico Fermi didn't build a telescope, didn't study interstellar objects. And we didn't invest a lot of funds so far in fact, we found those interstellar objects by chance. So my point is, once we invest billions of dollars, let's say $10 billion in this study, and not find anything, we would be exactly at the same point as the search for dark matter is. Most of the matter in the universe is of some unknown form, and we don't know what it is. It's sort of like a blind date. You don't know what you will find. And we've been searching for decades, invested more than $10 billion in the study, haven't found anything. Okay, but at least we tried, so we ruled out some possibilities. But if someone would have asked, just like at the time of Enrico Fermi, where is the sterile neutrino? Where is the axion? Where is the weakly interacting massive particle? I don't see any evidence for it. You would tell that person, of course you can't see evidence for it because you didn't put the billions of dollars in the search. But somehow, in the context of aliens, it's completely folklore to say we haven't seen anything, and extraordinary claims require extraordinary evidence. There is no extraordinary evidence, therefore no money should be allocated to the search. It's a self-fulfilling prophecy. If you don't seek something, you will not find it, and you can maintain your ignorance by not looking through the telescopes. That's exactly the approach that the Vatican had when they argued that Galileo should be put in house arrest. They not only were upset that Galileo looked through his telescope for the first time and found evidence that Earth is not at the center of the universe, but they banned the dissemination of this information and did not want to look through the telescope. That's an active approach to maintaining your ignorance. They basically wanted to remain ignorant about the data that you can get from a telescope. Why? Because it violated their prejudice. Okay, so those people who say no funding should be allocated to the search for technological signatures, they want to maintain our ignorance. Look at it that way, because if they were really curious and open-minded, they would say, let's put a few $1 billion in that search, the same way we are searching for dark matter or the same way we are searching for microbes. Let's just do the same thing for a very fundamental question that everyone is curious about, the public cares a lot about. Let's put also a few $1 billion in that direction. No, we will not put that, because it's an extraordinary claim. Well, what about the extraordinary claim about the sterile neutrino, which happened to be wrong? What about the extraordinary claim about supersymmetry, which happened to be wrong? There are lots of mistakes that the mainstream of science made where we didn't find what we were seeking, and that's after investing the billions of dollars. So I'm saying you are not allowed to ask Fermi's question until you put the billions of dollars in that direction. It's a question of the order. Okay, first you put money into the search. So if you are a lonely person, first you go to dating sites, you look for people. If you don't find anyone, you can then make the case that you are alone.
Absolutely. And that's an important point to make, I think. The quote, "and yet it moves," by Galileo as he's leaving the Vatican after being threatened to not talk about it, potentially being burned at the stake, still has the courage to say, "and yet it moves," kind of in opposition to this force. That's one of my favorite quotes, I think. Definitely, it's up
By the way, now we know that the Earth was moving around the sun 4.6 billion times. 4.6, just keep in mind, 4.6 billion times before the Vatican even existed. Then the Vatican comes along on this Earth that was moving 4.6 billion times and says, no, it's the sun moving around the Earth. Who cares? Like, in the cosmic scheme of things, humans can make mistakes all the time. All these critics who say, we don't have a neighbor, there is no extraordinary evidence for that. Who cares? If the neighbor exists, it doesn't really matter how ignorant we are. We can stay ignorant, we can avoid the investing in this search, and we just will not know the truth. But the reality of the matter will not change just because people say that it's an extraordinary claim.
And let me ask you this, because you see this, everywhere, of course, this idea that people tend to stick to their groups, they care about other people's opinions that they respect, and it feels like maybe it probably happens in scientific communities less, because scientists are trained to be more logical and stuff, but it still happens a little bit. We want to be liked, we want to be respected. No?
I would say it's not happening less, because I'll give you an example. The mainstream of theoretical physics, you might say this is the frontier that is advancing what we know about the physical reality. Physical reality, that's what physics is all about, right? The mainstream community of theoretical physics over the past half a century was advocating the notion of extra dimensions in the context of string theory. Not only this approach of extra dimensions string theory did not lead to an experimental test. It didn't lead to a prediction that can be tested in principle. There is no experiment planned for the next century that will test string theory. And if you were to ask a string theorist, what is your prediction? They would say, string theory must be right. It's only some conjectures that I can make that may be wrong. In fact, this is a direct quote from one of the leading practitioners of string theory 2 weeks ago after a talk that he gave at the Institute for Theory and Computation, for which I serve as director. So I asked him, you're making a prediction right now, and that's great, about cosmology. He made some prediction, and I said, that's great. So if we go out and test this prediction, would it prove that string theory is wrong? And he said, no, string theory must be right. It's only my conjecture. So you can't do that in science. You have to stick your neck. You have to say, okay, this is a prediction that I make, and if it turns out to be falsified, then my idea must have been, my theory must have been wrong. No, but in this case, if you prove it wrong, no, string theory is still okay. So then how can you claim victory if it happens to line up with future experiment? So this is a whole culture that for half a century basically was mathematical gymnastics. And it doesn't, there are many versions of the theory. We don't know which one is correct, so there is no prediction. When you ask about specific examples, like what happened before the Big Bang, what is inside a black hole, they say it's too complicated, they cannot make a prediction. So this is the mainstream that claims to lead the frontier of physics according to Brian Greene.
Yeah.
Okay, just look at Brian Greene. Every other week he talks about string theory being at the frontier, but it's already 50 years. We haven't seen any prediction that is tested or will be tested in the coming century. And what are we talking about? That supposed to describe the physical reality. So the question is this really the mainstream that we should believe? Is this really not speculative? Much less speculative than saying that something like us exists near another star or existed for billions of years before us. After all, that is a matter of common sense. If you see 100 billion stars, most of which formed billions of years before the sun, okay, most of the stars we know formed billions of years before the sun. Takes less than 1 billion years for the Voyager spacecraft to cross the entire Milky Way galaxy. There was plenty of time, even for the technologies we used in the 1970s, Voyager. Even for that technology, it takes less time to cross the Milky Way galaxy than the time difference between the formation of most stars, relative to the sun. There was plenty of time for them to arrive at our backyard. And for some reason, the possibility that we might find a technological relic is highly controversial. And people keep attacking me, even personally, just by proposing to leave it on the table as a possibility. And you ask yourself, how is that reasonable that extra dimensions, string theory for 50 years is able, and of course the answer is those critics that attack me, they say nothing about string theory because there is a whole community there. And what is the power of a community? It's just like a religion or a cult where you don't need experimental verification. And anyone that deviates from the herd, is immediately attacked or sidelined or marginalized. And they have their own set of belief, and they have their own criteria for what is impressive, what is not. It's based on some intellectual gymnastics and some mathematical virtuosity and things like that. They have nothing to do with the physical reality. And so the fact that you can have this construction of a community that dominates the mainstream of theoretical physics for half a century within science, makes you wonder if there is anything different between the social forces within science and what you find in religious cults. Because I'll give you an example. There is the Lubavitch community in Brooklyn. You might be familiar with it. And they believed that their rabbi will become the Messiah after he died. And then he died. And he didn't come back as the Messiah. So what did they say? We just have to wait. Right. There was no way for this theory to be falsified. And I'm asking, if there is no way for a religious belief to be falsified, what is the difference between science and a belief system? The main difference is you should put the head of a theory under the guillotine of experimental verification, because only when the experimental verification chops the head of the theory, then you know that the theory is wrong, and then you move on to some other theory. And that's the way science makes progress. Learning is done through making mistakes and eventually figuring out what's right. But if we don't have feedback from experiments, we can't do that. So it's not just a nuance that you can say, okay, for the next century, forget about experiments, let's just think about whatever we want to imagine. No, it's a very substantial point that without this ingredient, we can't make progress, okay? So if you are taking away the most essential aspect of doing physics, and you are claiming to represent physics, sorry, you are misrepresenting physics, because you are supposed to, put the theory under the standard procedure of experimental verification for it to become a physical theory and not a mathematical theory.
Right. And well, at least maybe misery loves company. This is a problem that you see across the entire world. I mean, how many politicians have said, just give me this money and I'll fix the problem? And they don't. And they say, I need more money to keep working on it. And it just goes on forever. So
yes.
It's definitely.
Also, I completely disagree that that science is doing better than than politics or religion. I think we have the same issues across the board. And for us to make progress, we need to hold, the practitioners responsible for what they're doing. We can't just let everyone be loose and do whatever they want, because that's, the definition of this profession is such that you need to verify ideas by experiments. That there is no way. Otherwise it's not physical science.
Okay, so help me
say
imagine
one thing.
Yeah.
I just always had this. Just want to always say to the people listening, you gotta support the heretics. You gotta support your local heretics, the people that speak out against kind of the orthodox things. It is important that we have those people that are okay with being canceled or not being liked by the community, that they still are allowed to speak, because very often they're the ones that end up being right, and then of course later we're like, of course they were right all along. So just kind of throwing that out there. But
let me just explain that I'm not a heretic. I'm in leadership positions. I was chair of the astronomy department for 9 years. I chaired the board on physics and astronomy of the national academies. So I know what I'm speaking. I'm coming from the same culture. I'm just speaking out what seems to me like common sense. And the fact that it doesn't line up with what some other people are saying, you can evaluate for yourself what makes more sense to you, because common sense is not always common in academia.
Sure, I meant more like Galileo, like somebody that at the time they were like, we need to shut this man down. He can't talk. Let's burn him at the stake.
But you might say, okay, that's a history. But since then we evolved. Now we have science, and then you glorify science. I'm just saying you can't do that, because just look around at the practitioners of science, and whenever they misperform, you should speak out.
Yeah, well, and it's just so hard to get somebody to believe something when their paycheck depends on them not believing it too. So if you had unlimited resources, and let's say we could get past this sort of political, cultural issue with money, both in science, politics, and everything, how should we spend the money? Like, what would you do, and how would people hold you accountable if you didn't accomplish your mission?
Right. So first of all, the most important aspect of the physical sciences is experimental verification. Okay, so I would cultivate the culture. The entire culture should be centered on checking, being guided by experiments. Just, that's the way that quantum mechanics was discovered. We didn't imagine it to be that way. And in fact, Einstein had problems understanding it. So for us to fool ourselves that we can figure out how to unify quantum mechanics and gravity just by pure thought is is really arrogant. And I do think we should, for example, in the context of unifying quantum mechanics and gravity, we should find experimental pathways to unraveling how to do that, because quantum mechanics itself was not anticipated. But in the context of doing that, we should always think outside the box and cultivate innovation. And the way to do that is encourage people to deviate from the doctrine, from the beaten path. And the way to do that is reward them if they open new pathways rather than punish them. And what happens right now is there are all these echo chambers of people who advocate, maintaining the views we had traditionally, and they just, because that way we don't make progress and we keep staying in the same place, And so how do you cultivate a culture of innovation? You give grants to people who are opening new, or at least trying to open new pathways to knowledge. And if they fail, of course, it's just like investing. You might invest a certain fraction of your funds in bonds, some in stocks, so you can then have a diversified portfolio where you don't lose all the money, but at the same time you might actually have great benefits from the risky investments. And even if a small fraction of them turns out to be beneficial, then they might pay for everything else. That's the way I see it. And I actually wrote 13 years ago or 14 years ago, I published an essay, an opinion essay in Nature magazine about that. And so I think it's just a question of diversifying our portfolio and investing a fraction of our research funds in the direction of risky propositions that are not accepted as the mainstream approach to solving the problems we have. And perhaps one of them will actually provide us with a breakthrough that we need to move on. I think that's what's missing with the current funding system, which is centered around the selection committees that are filled with people that have all these echo chambers, and they keep doing the same thing they were doing, giving it to friends that are doing the same thing, and it just doesn't bring us closer to the truth.
Yeah, and of course, Geoffrey Hinton, the godfather of AI, I mean, for a while there, he was going against the crowd, the consensus, in talking about neural
Exactly.
nets. Yeah. And now, of course, everything that we're seeing, this massive build out, all this AI craziness is as partly, a big part, thanks to him going, nope, this is going to work, this is going to work, this is going to work,
Yeah.
you know,
And
and here we are.
just look a century ago at quantum mechanics. The foundation of quantum mechanics was worked out by Niels Bohr. I actually visited Copenhagen, and I really wanted to go back in time 95 years just to the same place and speak to all these luminaries that founded quantum mechanics. Albert Einstein was arguing with Bohr in saying that no, it's still similar to classical physics, and there couldn't be spooky action at a distance. And Niels Bohr was quite courageous. He said, no, it's a new way to think about the physical reality. And he was right. And now all the gadgets that we use, including AI, are based on quantum mechanics. So, as you say, when you open up a new understanding of reality, it's the foundation for future technologies. It will definitely have applications that will be beneficial to society. And we just have to focus on innovation, I think, much more than on repeating the mantras of past knowledge.
Yeah. Well, the whole idea that you talk about with cosmic modesty is something that resonates with me. I mean, modesty in general across the board is something we need more of. And in our space, where Wes and I are watching intelligence sort of transform day by day with many different architectures and definitely different modalities, it's like we have to have some sort of intelligent modesty also. Like the human brain is probably not the pinnacle of all intelligence.
Exactly.
And even though it feels that way.
Yeah, so I think we are about to discover that we're not at the top of the food chain, and there could be two reasons for that. One, artificial intelligence. Our own kid may be smarter than us. It's just like you give birth to a child, and child happens to be better than you. That happens to many of us. And this is a technological kid that we gave birth to, and might supersede our cognitive abilities. We might not recognize it at first. Maybe already it does. And in some aspects, it may be like a genius that, in some practical aspects, we can still do better, and we can be proud of that. But in some other aspects, it's already beyond us. Okay, so that is one type of AI that we will face in the near future. And the second type of AI is alien intelligence. And that could be even more overwhelming. And that's what I'm trying to find. And, there is, of course, a question of language, of how to communicate if we do find alien intelligence that is superior to ours, or whether they even care about us. We tend to think that anyone coming to the solar system is doing it because they want to visit us. Just like Enrico Fermi. Where are they? Like, why aren't they showing up at Los Alamos? Like, who cares about you? Who cares
Nobody
about
wants to date you, bro.
Yeah, like, why is that such an important goal for aliens to visit you at all? Like, the Earth is just a tiny rock, 3 parts in a million of the sun, that left over from the formation of the sun. The bigger player in the solar system is Jupiter, and if anyone would come, would embark on a journey of that takes 1 billion years, they might target Jupiter, not Earth. It's not clear what their goal would be. So altogether, I think it will bring us to a sense of humility that we never had before. And it may be a substitute to traditional religions that envision the superhuman entity in the name of God. Okay, so even for secular people that do not believe in God, like Nietzsche said in 1882, he said that God is dead. Once we encounter alien intelligence superior to ours, we might have a sense of awe that is similar to traditional religions. And I think in in the distant future, that would be sort of the new religion, where there would be something in reality that is just a neighbor that happens to be much more wise and capable than we are. You can think of it as a sibling of our family of intelligent civilizations that happens to be more accomplished than we are, maybe because they had more time to develop science and technology. Doesn't matter, but for us, it will be a learning experience. And, then we look back and at all these critics who say, oh, it's an extraordinary, it would look completely ridiculous, like a bunch of monkeys on a planet saying, oh, we are the strong, like we are at the top of the food chain, and then not realizing, just like the church didn't realize that the earth moves around the sun, not realizing that you are just a drop in the bucket, and there is much more out there that is far more accomplished than we are. And I think that will bring humanity to a better place, recognizing that.
Absolutely. That's very well said.
I don't know if you're doing it, but it seems to me like if I was you, I'd probably be trying my best to sit down with people like Demis Hassabis and Sam Altman, or at least as close to those people as you can get inside their companies to see how you could use AI to expand your search.
I would love to do that. I would love to do that. Yes,
absolutely. And we have to be respectful of your time. I know you have to go. So thank you so much for giving us this time. This was absolutely amazing. Just one last quick question, maybe 10-second question. Assuming there is some sort of biosignature or techno signature out there that shows that there's something else out there, you believe that it's out there, we're just not seeing it yet. Is that your kind of like, okay, that's, yeah.
And, if it's not out there, then of course I will not find anything, but I think we should give it a try because it might be out there. And usually in life, it's important to be an optimist because sometimes life is a self-fulfilling prophecy. So if you're not seeking a partner because you said it doesn't exist, you will never find it. But if it exists, you might find it. So I very much.
Imagine how different the world would be if we all, like, if people just, the culture was we believe in aliens and we put so much resource into it and we believe they're out there, we'd probably still say we need more time. It's a huge universe out there. We wouldn't be depressed that we're lonely. It's an interesting
right.
take.
And, it takes time for us to make discoveries. It's already almost a century since we found there is dark matter. We don't know what it is. So we should be patient, but invest resources in the search. That's key for us to learn something new. And at any event, my next commitment is to a forum called State of the World 2025, which is very fitting to what we just discussed.
Okay,
absolutely.
I'm glad we can warm you up.
Thank you so much. Very optimistic, very fascinating. Thank you so much. Good luck to you in all your endeavors. And to the listener, thank you so much for watching. We'll see you in the next one.